two categorical variables. This might be male and female and color of car. Maybe red, white, and black seem to be fairly popular colors. Let's think of this way for right now. Let's suppose that I'm in some kind of big classroom or seminar or something like that. And I go out in the parking lot during a break. And I count in the parking lot. And I know everybody has driven their own car there. And I go out in the parking lot and I count 60 red cars, 100 white cars, and 40 black cars. Then I count the number of males and females in the place. 100 of each. If there were no relationship between gender and car color, how many males would you expect to be driving a red car? 30. If there's no relationship, whatever this proportion here, I happen to have a 50-50 split, 100 males and 100 females, so I would expect 30 and 30. There's an even split of males and females, so I would expect, if there's no relationship. So this is HO. There is no relationship between gender and car color. So here we're saying there's no difference or no relationship between these two categorical variables. So now let's say that we went out and we collected some data, and that this is what we observed now. Of course, this hasn't changed. The cars are still in the parking lot, and there's still 100 males and 100 females. But now, I sit out the window and watch people get in their cars, kind of like a spy game or something, I observed this. So let's just say we came up with those numbers. This is what I actually observed. Let me go ahead and write here. This is what we expect if no relationship. So do you think there's a relationship? It looks like it, because these numbers are far from what you would expect if there's no relationship. There is a relationship between gender and car color. We'll call this example data 1. So let's say, now that wasn't the data. That's one possibility. Let's say that we had this data. This is degrees of freedom. This problem has 2 degrees of freedom. Because now, once I've entered those two numbers, again, I've already looked out in the parking lot and I've counted the people in the place. Now, once I've actually gotten that there are 32 males in red cars and 51 males in white cars, everything else is determined, not free to vary. I know that this has to be 28 because there were 32 of these. This has to be 49. Let's see, that's got to be 17, and that's got to be 23. So when you do degrees of freedom for the chi-square test, the way I do it is, let's say if it was this problem over here, is just blot out one row and one column, so this one would have 6 degrees of freedom. Once you have 6 numbers in there, and you know what's out on the margins, nothing else is free to vary. To me, that's the easiest way to understand degrees of freedom. We've been using it before when we did it with standard deviations, the reason you had n minus 1 is, suppose you knew the mean, and you had 6 numbers. Well, if you know the mean, only 5 of those are free to vary. Once you know the other 5, you can just compute the other one. To me, it's true. That is degrees of freedom when you do means, but this is just easier to explain. So, based on this example data too, do you think you can conclude that there is a relationship between gender and car color? Here we said there is a relationship because these are far away from what you would expect if there's no relationship. But these are pretty close to what you would expect if there's no relationship. Therefore, I'm not going to reject HO. I'm going to conclude that there might not be a relationship. Again, because the numbers here are reasonably close from here. You're going to expect, if there's no relationship, that there's going to be some sampling variability, sample to sample. If we went to another place and there were 100 males and 100 females, and we had the same numbers for red, white, and black, you're not going to get exactly 30-30 every time if there's no relationship. Not vary some, but 32 and 28 are pretty close to 30 and 30. 51 and 49 are pretty close to 50-50. And 17 and 23 isn't that far from the 220s. So the way the chi-square test works, and we're going to write a formula and everything, but the way it works is we have our observed data. We can figure out what we would expect if there's no relationship. So, if it's this one, example 1, we just compare this to what we would expect if there's no relationship. If they're close, we say there might not be a relationship. If it's far away, we conclude there's a relationship. And again, these are pretty far away from that. 20 and 40, pretty far away from 30 and 30. So we think there's a relationship, and of course that goes the way. And again, over here too, we compare the numbers here to what we would expect if there's no relationship.